When I was young, my mother used to send me to purchase groceries from the local noisy market. The noise of countless shoppers and street vendors calling out the prices on top of each other created a daunting experience for me. However, my mother armed me with the knowledge of which vendors to approach and what prices I should pay for the produce I bought. Little did I know that this early lesson would be valuable in shaping my future journey in AI development. Today, AI development is a noisy space, steaming with endless possibilities. Amidst this rapid progression, there is an emerging challenge to identify valuable AI solutions from the noise. I am a moonlighter who merges expertise in data science and software engineering to build AI. I use this experience as I embark on my research journey to tackle this issue head-on. Code is a pivotal building block of AI. AI code is intricately woven by interdisciplinary teams consisting of data scientists, specialists in AI algorithms, and software engineers who build the infrastructure to incorporate these algorithms into useful solutions. Various tools exist to aid these teams, but the cultural differences existing between software engineers and data scientists prevent them from adopting these tools to aid them, resulting in AI failures. Drawing inspiration from my grocery shopping experience, I realized the power of context. By using the knowledge from the technical domain, the problem domain, the nature of the code, and team norms, I developed a context-driven tool that not only highlights the problematic areas in code, but also provides efficient fixes. This improves the quality of the code and reduces the time to implement these fixes. But this was the icing on the cake. As I dove deeper, I realized to build valuable AI solutions, we need to select and evaluate the right AI models. With countless options out there and limited availability of data, how do we pick the right one? Generally, a trial and error approach is used, but this approach is wasteful in terms of time and computation, leading to increased costs. My solution? By using context as a driving compass, I developed a tool that leverages the information from the deployment environment and the nature of the problem to effectively reduce the space to search. And using Bayesian algorithm and ChatGPT, I can evaluate this space to find the ideal model. My solution is far quicker and computationally efficient than the other approaches, reducing the overall cost. My research allows us to navigate through this noise to fast-track valuable AI solutions. By using context to improve code analysis and model selection techniques, we can rise above this noise to build an impactful and sustainable AI future. Thank you.